Ever wondered how the world of mathematics connects different elements together? Well, that's what we're diving into today, with a focus on relations and functions. Now you might ask, what are relations and functions? These are two key concepts in mathematics that help us understand the connections and interactions between different sets of numbers or elements. Let's start with relations. In the simplest terms, a relation is a set of ordered pairs. An ordered pair is a pair of mathematical objects in which the order of the objects matters. For instance, AB is different from BA. So a relation pretty much maps one set of objects to another. Functions, on the other hand, are a special kind of relation. They are a set of ordered pairs as well, but with a twist. In a function, each element from the first set is related to exactly one element in the second set. This means that if you have a set of numbers, say 1, 2, and 3, and you want to map them to another set, say 4, 5, and 6, each number from the first set can only connect to one number in the second set. Now, why are these concepts so important? Well, relations and functions form the foundation for much of the mathematics we use in everyday life. They help us understand how different elements interact with each other and provide a framework for solving many mathematical problems. You'll come across these concepts in various areas of mathematics, from algebra to calculus, and even in other scientific disciplines like physics and computer science. They are integral to the structure and logic of the mathematical world. So, you see, relations and functions are more than just dry mathematical concepts. They are the threads that weave the intricate tapestry of mathematics, linking different elements and ideas together in a coherent logical framework. With that, we've laid the groundwork for our exploration of relations and functions. Ready to dive deeper? To understand relations and functions, we first need to get a handle on the Cartesian product of sets. So what exactly is a Cartesian product? Imagine you have two sets, let's call them set A and set B. The Cartesian product of set A and set B, written as AXB, is a set of all possible ordered pairs, where the first element is from set A and the second element is from set B. Now, you might be wondering, why is this important? Well, the Cartesian product is foundational to understanding relations and functions. You see, a relation is simply a subset of a Cartesian product. It's like picking out specific pairs from the product that follow a certain rule or pattern. So, by understanding the Cartesian product, we're laying the groundwork for understanding the more complex concepts of relations and functions. Now that you have a grasp on Cartesian products, we can start building up our understanding of relations. So, what exactly does it mean for elements to be related in the mathematical sense? Well, in the realm of mathematics, a relation is a connection or association between two or more elements. It's like a bridge that links different elements together. But how do we form these bridges or relations? It all begins with the Cartesian product of sets. Picture two sets of elements. The Cartesian product is simply all possible pairs you can make by taking one element from each set. Each of these pairs forms a relation, and the collection of all these pairs is called a relational set. Now, imagine a set of people and a set of places. A relation could be lives in. So the pair, John, London, is in the relation if John lives in London. It's as simple as that. But remember, the order of the pair matters. John, London is not the same as London, John. Relations have different properties that classify them into various types. Some are reflexive, where every element is related to itself. Some are symmetric, meaning if an element A is related to B, then B is also related to A. And some are transitive, meaning if A is related to B and B is related to CE, then A is related to C. Understanding these relations is crucial in mathematics because they provide a framework for exploring and organizing mathematical concepts. They help us see patterns and connections that we might otherwise miss. To sum it up, relations are about connections or associations between elements. They're formed from the Cartesian product of sets, and they exhibit different properties like reflexivity, symmetry, and transitivity. They're not just abstract concepts, but tools that enable us to navigate through the vast landscape of mathematics. Now that we've established what relations are, let's move on to the other half of the equation, functions. Functions might sound complicated, but they're actually a logical extension of relations. Now let's dive into the realm of functions, shall we? A function in layman's terms is like a machine. You feed it an input, it processes it according to a set rule and then produces an output. Sounds simple, right? Well, there's more to it, of course. We have several types of functions. Let's start with the identity function. This function is the simplest of them all. It's like a mirror, reflecting back whatever you feed into it. If you give it a 5, it gives you a 5 back. If you give a -3, it returns a -3. Next, we have the constant function. This one is a bit like a stubborn mule. No matter what you feed it, it always gives you the same output. If you have a constant function set to 2, it will always spit out a 2, regardless of the input. Moving on, we have the polynomial function. These are a bit more complex. They involve powers of the variable and can create beautiful curves and lines when graphed. Then there's the rational function. These are ratios of two polynomial functions. They're a bit trickier, but incredibly useful in many mathematical contexts. We also have the modulus function, which measures the distance of a number from 0 on the number line, disregarding its sign. Then we have the signum function, which simply tells us whether a number is positive, negative, or 0. And finally, we have the integer function, which rounds off a real number to the nearest integer less than or equal to it. And don't forget about the algebra of real functions. It's like the grammar rules for how functions interact with each other. Every type of function has its own unique properties and uses, and understanding them can unlock a world of mathematical possibilities. And that's a wrap on functions, but how does all of this fit together? Now that we've covered all the individual components, let's see how they connect. As we've journeyed through this chapter, we've learned about the fundamental aspects of relations and functions. We started with an introduction to these concepts, laying a solid foundation for our exploration. Remember, relations and functions are two key elements in mathematics that establish connections between sets of data. We then delved into the Cartesian product of sets, a tool that helps us understand the possible combinations of elements from two or more sets. This is crucial in understanding the concept of relations, which we looked at next. Relations, as we learned, are essentially a set of ordered pairs derived from the Cartesian product of two sets. After understanding relations, we moved on to functions. Functions are a special kind of relation where every element of one set is associated with a unique element of another set. We went through different types of functions, including the identity function, constant function, polynomial function, rational functions, modulus function, signum function, and integer function. Each of these functions has its own unique properties and applications, making them indispensable tools in mathematical problem solving. We also discussed the algebra of real functions, which is the study of operations such as addition, subtraction, multiplication, and division on real functions. This is another key skill that helps us manipulate functions and solve complex mathematical problems. You see, all these concepts are interconnected. The Cartesian product of sets leads us to relations, which in turn leads us to functions, and the algebra of real functions helps us manipulate these functions to solve a myriad of mathematical problems. It's a beautiful, interconnected web of mathematical concepts that empowers us to make sense of the world around us. And there you have it. A comprehensive look at relations and functions. Keep practicing and you'll be a pro in no time. It's been a journey, hasn't it? But we made it through the vast world of relations and functions. We kicked off our adventure by understanding these core concepts, then navigated through the Cartesian products of sets. Remember how we uncovered the fascinating intricacies of relations and then delved deep into the realm of functions. We explored a variety of functions, from the identity and constant functions to the polynomial, rational, modulus, signum, and integer functions. We even got our hands dirty with the algebra of real functions. Every step of the way, we discovered connections, patterns, and the beauty of mathematics that shapes the world around us. But our journey doesn't stop here. There's a vast universe of mathematical concepts still waiting to be explored. So keep that curiosity alive. Keep asking questions, keep digging deeper, and continue to unravel the mysteries of mathematics. Thanks for joining me on this mathematical adventure. Until next time, keep exploring the patterns and connections in the world around you.